The next we have Abhishek Pokharel. Abhishek is currently with Century Water Control and Monitoring Incorporated in Charlottetown, Prince Edward Island. He completed his MSc at the University of Prince Edward Island and has a bachelor's degree in environmental engineering from Kathmandu University in Nepal. He graduated in 2020, and today he's going to be speaking about work that was completed while he was a Climate Sense intern in 2021 for the city of Charlottetown and the town of Stratford, Prince Edward Island. So I will pass it over to Abhishek.
Thank you, Dan. Greetings, everyone. So I'm Abhishek Pokharel, and I bring you the use of PIEVC high-level screening guide use in the Maritimes. So before moving forward, first of all, I would like to acknowledge PEI as the traditional and unceded territory of the Mi'kmaq First Nations, and I'm very grateful to be living and working here, and thank you for the opportunity. So next slide. So as Dan previously mentioned, my name is Abhishek Pokharel. I did my MSc Sustainable Design Engineering from University of Prince Edward Island in Canada. I hold a BTech in Environmental Engineering degree from Kathmandu University, Nepal. So this particular work is done as a climate sense infrastructure resilience intern in 2021. So basically, this is my first job, and a disclaimer on to everyone that this is an amateur work, and will be very happy if there is a lot of feedback from every one of you. So, and in my current position to talk about is I am a client manager at Century Water Control and Monitoring Inc. Still working with Wastewater. So yeah, next slide. So before moving into the project itself, I'd like to explain a little bit on Climate Sense internship. So it's Natural Resource Canada's under its BRACE initiative. So it is bringing in a recent post-secondary graduate student, someone like me, and hooking them up with public and private sectors in PEI. So in this case, the city of Charlottetown and town of Stratford. And what we do is we work with UPEI, Climate Lab, our host organization, and different other organizations around in the island, and work towards certain sector-specific adoption projects. During this internship, I was involved in a lot of other projects, green shorelines, coastal hazard assessments for properties and stuff like that. But today I will probably talk on my work with wastewater treatment system in the city of Charlottetown and town of Stratford. Next slide. Next slide, please. Yeah, so I'll just like to start this with the scope. So basically, the scope for this project was already defined by the municipalities for me. So they had their climate adaptation plan, climate action plans, adaptation mitigation, and all those plans, which did a lot of risk analysis and all those works. But what I was asked to do on this specific was provide with those values they can use to quantify the cost related energy expenditure and other things that come up with the changing climate. So for this particular study for wastewater, I had two objectives on this. This objective first being analyzing resilience of existing wastewater infrastructure against coastal hazards, which are more towards the town of Stratford, and also looking at the risks that comes to city infrastructure, especially wastewater treatment system and the pumping stations due to the changing climate. Next slide, please. So introducing the area of this study is the Charlottetown and the Stratford. Stratford is the Triceratops looking projection on bottom right, and Charlottetown is on the top. So just looking at the map, you can see the density of population in these two areas, right? So Charlottetown population is, so Charlottetown and Stratford share a same treatment system since 2021. So Charlottetown and Stratford has combined population of around 50,000, but again, this number changes from 50 to, it doesn't take much to go across 100,000 in summer during tourist season. So there is a lot of those flows, and also there are flows that comes in from unsewer lines like rentals and coast houses. So it's the same. And yeah, and the average flow that was detected during this period of study was around 20,000 cubic meters per day. So just a little background on this is Charlottetown has separated its sewer system from stormwater since 2015, and Stratford Sewer has its own collection system, but however, it sends water over the bridge for treatment, and it pays for per cubic of water that is being sent for the treatment. Next slide, please. So, like I mentioned, it's an amateur work, and I was not very familiar with how to get those climate data and work with it. So I just kind of cheated a little bit on this one. So I did a reverse work. So instead of identifying climates that might impact the infrastructures, what I did was, what are the things from the environment that can impact the infrastructures? One was water outside and inside the pipelines. Inside is basically because of inflow and infiltrations, and outside coastal hazards, and also an issue with power failures, which is again looked from a different perspective. So with this, when I got this information, I backtracked into finding information on the changing climate and predicted climate with the help of the UPEI Climate Lab. So it's putting these two results together and getting something for the municipalities to look at. Next slide, please. So for this, the most important part of this study was gathering of data. So the first part of data is something from historical data. So as I was working for coastal changes, and you might have heard over the news that how Prince Edward Island has a lot of coastal erosion and flooding issues. We have a lot of our very beautiful beaches destroyed after the recent Fiona event. So it's a big issue in and around PEI, especially, and also in and around Stratford. So luckily what I had through PEI Department of Environment, Energy and Climate Action was a coastline change since 1968 to 2010. And recently, when I was doing this internship, PEI Climate Lab added to this already established data and brought in data from 2020. So we do have something, measurement of how much erosion did happen, how much mass was added to a beach, and those kind of data. And similarly, there is also resources on different shore types around PEI, especially around. So I use this data in and around Charlottetown and Stratford area to determine what kind of shoreline this is. Is it a salt marsh? Is it sandy beach or something, or what is the probability? So this kind of helps me to identify the probability of the particular shoreline being eroded. Next slide, please. So on top of that, I needed some predicted data, right? So through PEI Department of Environment, Energy and Climate Action, again, and in collaboration with PEI Climate Lab, we have something called Coastal Hazard Information Platform. So this is a screen that I have put screenshot of the platform that we can get. And you might see on the left side, you can see some parameters that we can see being laid over the maps of Charlottetown and Stratford. So basically, we have predictions for high flood hazards for 2020, 2050, and 2100. So based on different level of hazard intensity, we can use this map for analyzing post-hazard assessment. Next slide, please. And finally, so to talk about inflow and infiltration, what I did was, so I learned sanitary sewer overflow analysis and planning toolkit from US EPA, and UPEI Climate Lab had established local weather stations in and around Charlottetown, so got data from them. And using this to data and computer programming, what I did was I tried to model the sewer system of Charlottetown as well as Stratford and gather data on how the rainfall is affecting this particular sewer network. Next slide, please. So, and the secondhand data, I think this is one of the most important resources of data that I could think of. So these were the data, informal data, as I like to call it, secondhand, I got from traveling with operators on the truck when they were doing maintenance and everything. So asking them a lot of questions, what's happening, what happened there, why this pump station down, what happened in 2015, what happened in 2018, and things like that. So this was a lot of helpful. So this kind of helped me to identify those vulnerable areas, the vulnerable assets like pumping stations, those old 1970s, 1980s pipeline system, those old houses that had that doesn't have a sump pump and connects it directly to the sewer network and those kind of stuff. So yeah, this was a great source of data as well. Next slide, please. So on the third step of this process was assessment. So on this part, so for the coastal hazard assessment, what I did was with the secondhand data and all that information, identifying the important and most vulnerable pump stations in and around Stratford. So on the left figure, you can see a little red triangles. These were the pumping station which serviced a higher number of population and were very vital for the whole treatment, the whole collection system. So based on the data that I had previously from on coastal chains and flood hazard, I overlaid on GIS with these locations and identified infrastructures like pumping stations shown on the right side. One of the stations called Bayside, which is very close to the shoreline and in the flood zone. This is because this is one from back 1970s or 80s pumping station, and people used to build it very close to it was built very close to the coastline because of the natural gradient that it had. So, but it kind of looked a little problematic now. So next slide, please. So similarly, when I identified these vulnerable infrastructures and pumping stations, I forwarded this to the Department of Environment, Energy and Climate Action. They have an assessment process called Coastal Hazard Assessment. So what we do is I send the property number for the party where this infrastructure is located, and they do a coastal erosion hazard assessment and coastal flood assessment for that particular property. And this is one example for the Bayside that I just mentioned before. So you can see that for the high flood hazard, 35% of the land falls under it, and the minimum is at least 10% of it falls when there is a high tide. There's a storm surge during a high tide. Next slide, please. In addition to that, this is where I also carried out rainfall data inflow and infiltration analysis for the main treatment plant, which is on the left side, and also for the individual sewer shed for a pump station, which is on the right side. So on the left side, we have a wastewater treatment system inflow at the wastewater treatment plant. We can see a significantly high inflow and infiltration during one of the biggest rainfall on 2nd of September 2021 with 128 mm of rainfall. And if I'm not wrong, this is the second highest recorded rainfall ever on any place in PEI. And similarly, on the right side is the same day, but for Stratford. One thing I'm not sure how clear the graphs are, but one thing that we can see is on the Stratford, and it's more of like a quick rise due to the rainfall, which kind of says it's more of like inflow issue rather than infiltration. Whereas for Charlottetown, it's more of inflow and infiltration both. What this information does is it prevents Stratford from digging out their pipes and doing the coating. Instead, they can do a simple smoke test and identify the places of inflow. But for Charlottetown, they have to divide their whole sewer network into different sewer shed and identify each one individually. So from this data, I got a few numbers. So I didn't mention, apologies for that, I didn't mention exact number because I thought this was not very professional. So I can give you the numbers if you are interested on this one. But yeah, this much mm of rainfall per hour has significant impact on microbiology of the treatment. This was, I think, 17 mm of rainfall. Anything above or around that causes microbiology imbalance in the treatment unit. Similarly, for Stratford, for Charlottetown, I remember it's 10 to 12 mm per hour of rainfall. And finally, for Stratford, it was around 10, similarly 20, which was the threshold for the treatment. Next slide, please. Yeah, so for the risk analysis, again, based on these assessment, I got those numbers and the climate parameters that can impact infrastructure. So what I did was collaborated with institutions like UPEI for predictions and identifying severity, climate change, and impacts. So what I did was I calculated utilizing power resource and what power was used, how much extra power was used because of this extra flow coming in, decrease in pump run hours, irrigation, excess irrigation, and all that stuff, and also compare the cost of operation, decommission, and failure of the cost of that. So next slide, please. So on this part, so on this whole rig system, I came up with three important concerns. One was one pump station that I showed before had a moderate risk of coastal flooding and overloading. Second was a moderate to high risk to rainfall deriving flow infiltration in Charlottetown, and a low risk for RDII for Stratford. Next slide, please. So for now, what we see that pump station I suggested with short-term measures against coastal hazard, but as of now 2020, they had to build a new station to decrease the load for that particular pump station and doing work on that. Similarly, Charlottetown is working on its assess management and doing a master plan for the wastewater treatment. And for the Stratford, they brought in the bylaws for stormwater connections and pump connection into the system. And finally, for power failures, I just worked with some emergency response and backup power options with operators and the municipality. So next slide, please. Yeah, I think I'm done with it. And thank you very much. I'll be more than happy to answer any of the questions.
Great. Thank you very much, Abhishek. Very interesting case study from Atlantic Canada. And it's also good to hear from Abhishek as a new professional in this area. And we'll be very happy to get his thoughts as a new user of the PIEVC process and somebody who is relatively new to the adaptation space, climate risk assessment space when he did this work recently.